Hello everyone. In this video we look at the first part of the vertical straight line motion. Now vertical straight line motion is a type of motion in one dimension. So what the vertical straight line motion basically consists of? It consists of the study of an object or a particle which is moving along a vertical line, that's it. Okay, so that is what we are going to study in this. So here we will divide this vertical straight line motion into different types for the sake of clarity while we are approaching the problems. So while solving numerical problems, right, it will actually help us a lot if you can again dissect the vertical straight line motion into different categories. So in this part what we'll do is we'll look at broadly what are the aspects that we need to consider in vertical straight line motion, and also we'll see some of these like we said, we'll divide the vertical straight line motion into different categories, right? We'll cover some of these categories. In the second part we'll look at the other categories of the vertical straight line motion. So if we look at the vertical straight line motion, as we mentioned, we can categorize this into these four types. So one, if you have an object which is thrown upwards from the surface of the earth, like think about it, if there is a person who is standing very close to the surface of the earth. So here what is the assumption? He is holding that object very close to the surface. So here you might ask, okay, what about this distance? So assumption itself is what we neglect it. So it's like, we are holding the object very close to the surface of the earth. Now from there, if we want to give a vertical straight line motion for the object, right, there is only one possibility. What is that possibility? We simply have to throw it up. So if you throw it up, what is going to happen? Obviously you will throw it up with some velocity. What is the observation? Generally, if you take a stone and throw it up, right, what do we observe? We'll observe that this stone or whatever we throw up, right, will go up to some height. So that is what we call as the maximum height. Okay, so we'll go up to the maximum height. After that, it will start coming back. It will fall back. So this will be the journey of the object that we throw up from the surface of the earth. It will go to the maximum height, then it will come back. We will study about in this particular category of vertical straight line motion, what are the parameters or aspects that will be of interest to us, and what kind of questions can come, that we will study separately. Okay, so this is about the type 1 or the category 1. Now the type 2, 3, 4, they all start with the object already at a height above the surface. Type 1 is object is near the surface. Type 2, 3, 4, all of them will be what? The object is already at a height above the surface of the earth. Okay. In that, what is this type 2? A body is dropped from some height. See, when we use this word dropped, right, we have to be little bit careful. Why? Because if you have a stationary entity means, object, like say, you are standing on top of the building, you are standing still, so we will call you as what? Stationary entity. You are stationary. If you drop any object or body from a stationary entity, like you are stationary, you are dropping it, then the initial velocity will be 0, because you are stationary. You drop something means the object that you're dropping will have what? Initial velocity 0. But if you are dropping an object or a body from a moving entity, so you are dropping an object or a body from moving entity, like what? You drop an object from a moving car. Now don't think that we are again going back to the horizontal straight line motion. I am just taking an example. So think about it. You are going in a car, suddenly you release some food packet. Suddenly you are releasing some food packet. Now think about it. The food packet here is what? It is like the object that you are releasing or dropping from a moving entity. Then the initial velocity of that food packet will be equal to the velocity of that moving car. In vertical straight line motion also we can drop objects or we can release objects from the moving entity. Like a balloon is going up, we release something from the balloon. A balloon is coming down, we release something from the balloon. Like that we can have. Okay, so if you drop or release any object from a stationary entity, then the initial velocity of the object will be what? 0. If you drop or release anything from a moving entity, like that balloon which is rising up, or balloon which is coming down, or a car which is moving, then in those cases the initial velocity of the object that you are dropping will be equal to what? The velocity of that moving entity. Okay, so if you look at it, right, you are simply dropping. So what do you observe? The initial velocity, generally we will take it as u, right? Same, the notations whatever we use in the horizontal straight line motion, same notations we are going to follow here also. That is not going to change. Okay, so we drop it means what do you observe? This ball is going to keep coming down. It will finally reach the bottom or the surface. Okay, so while it is coming down, it will basically travel through this distance h, because you are dropping or releasing from the top of the building, right? It will basically travel through this distance h. We will study this type of motion also separately. Now let us go to the third type. What is the third type? A body is projected vertically upwards from the height. Look at this. It is like you are standing on top of the building height h and you throw it up. You know what you are going to observe? From here, it is going to go up to a height. Like the way normally when you are standing on the ground and throw it up, right? What you are going to observe? It will go to that maximum height that we mentioned, then it will come down to the surface. Here, we have to be careful. In this particular case, right, the assumption is generally that, okay, you are standing from the edge of the building or something and then throwing, which means it goes to the height, and we assume that it will be able to come and reach the bottom of the tower or the surface of the earth. So when is it going to be possible? Lot of students will have this doubt in the mind. Sir, when I am throwing something from the top of the building, like you are standing on the terrace of your own house, you throw something, what do you observe? You will observe that the stone will go up and then it will come and fall back on the terrace itself. No. But why are we saying that the object will go to that height? This is the max height or something, whatever we call it. It will go to that, and then while coming down, we'll say that it will reach to the surface of the earth, because while generally talking about this particular case, right, we assume that the person is standing or almost that that edge of that building and throwing. Okay, so this point we have to be careful, because this is, I have seen some students getting confused. So why is it that, okay, the object is going up and instead of falling on the building top itself, it is falling to the surface of the earth? Why? Because the assumption is it is like we are standing at the very edge and then throwing it up. Okay, so this part we have to be careful. So look at it. What will be the motion here? This is going to go to that maximum height and then it comes down. Where it is going to come down? It is not going to come down and fall on the top of the terrace. It is going to come down and fall back onto the surface of the earth. Okay, so this is the third type. Now let us go to the fourth type. What is it? A body is projected vertically down with some initial velocity from the height. So you can see all these 2, 3, 4 cases, right? They are all happening from that height. So here what are we doing? We are projecting it down. Second case is what? Dropping, means initial velocity was 0, u was 0. But in this case you can see u will not be 0. You will throw it down. You will basically throw it down with some velocity. And what is going to happen? This is going to keep coming down and it will finally reach the surface. Okay. Then you will ask, what is the difference between the case 2 and case 4? The difference is what? Case 2, initial velocity is 0. Case 4, you are having some initial velocity. As a result of it, what is going to happen? The journey equation is going to be slightly different. Okay, so the journey equation and journey parameters of motion will be slightly different. So when we go to the case 4, we will see what is the difference between the case 2 part and then case 4. So what we will begin with is, we will start with the assumptions, because in vertical straight line motion, right, we have to deal with some assumptions. The first assumption is that we consider the entire motion, whether we are throwing the object up from the surface of the earth, where it is going to go to the maximum height and then come down, or you are creating the vertical straight line motion from the top of the building. So top of the building, we have 3 cases, right? Either you simply drop it, or you throw it up from the top of the building only, or you throw it down. These are the three cases we have seen. Okay, in all these cases, right, we consider that the acceleration due to gravity throughout the journey, the acceleration due to gravity which is acting on that object will be always constant, which we will take it as 9.8 meter per second square downwards. Approximately some problems if they give us, we can take it as what, 10 meter per second square also. So we do not consider the small changes in the acceleration due to gravity with the height. Okay, because when we go to the gravitation chapter, we will see that if you go from the surface of the earth, if you go to the height, means we will have a formula in that gravitation chapter, how that acceleration due to gravity will vary with height. But here the assumption is what, the small changes in the acceleration due to gravity that will come with height, we will neglect it. Not only that, when you throw a stone up, or when you have any object which is moving in air, the air will create some drag force which we call as the air resistance, that we all experience. Like you are going on a bike also, you will see that there is an air resistance, right? But here when we are talking about the vertical straight line motion, we neglect the air resistance. Okay, we neglect air resistance, as well as we also neglect what, the small changes in the acceleration due to gravity. So acceleration due to gravity, we assume that it will be always constant. What is the value? We'll take it as 9.8 meter per second square. Sometimes we can even approximate it as what, 10 meter per second square. Now you may ask, what if we have to consider the air resistance? Then there is going to be some small difference, in the sense, the motion is going to have some slight deviation. What it is, we can expect some theoretical questions on that. If there is an air resistance, means what is going to be the impact of that on the vertical straight line motion. Okay, so we'll talk about it as we go into the discussion of the vertical straight line motion, but these are the two important assumptions we will make. Then for the 1D motion, right, we have used the equations of motion, because remember, what are we saying here? Acceleration is constant, means what, it is a uniform acceleration. Uniform acceleration, we already talked about it. We have the equations of motion. What are the equations? V is equal to u plus at, s is equal to ut plus half at square, then b square is equal to u square plus 2as, then Sn is equal to what, u plus a by 2 into 2n minus 1. All these equations we have seen. What are these? These are the equations of motion which we can use when the acceleration is constant or uniform acceleration. When we are using them, right, in the 1D motion, we have to follow the sign convention. In horizontal straight line motion, already we have covered that in the previous videos. We have taken a sign convention. What is it? If the quantities which are in the direction of the initial velocity, we take all of them to be what, positive. The quantities which are in the opposite direction, we will take them as what, negative. That is the sign convention we follow. Basically, one direction, whatever the vector quantities, we allow to take them as the positive values. Opposite direction vector quantities will be taken as what, negative. That is the sign convention. Now what is the sign convention we are going to follow in the vertical straight line motion? Generally in the vertical straight line motion, right, the sign convention that we use is, because we have different cases, like we already talked about it, right, case 1, case 2, case 3. Sometimes the object may be going up, sometimes the object may be coming down. So some people, they might still go with that same convention. So what is that convention? Whatever the initial velocity direction, they will take it as positive, and the direction opposite to the initial velocity, they will take it as negative. So this is the same type of convention that we are used to in the horizontal straight line motion. But what could be a more simplified sign convention to follow, which will ease out our tension of making mistake, is if we can fix, because we know anyway there are two standard directions we can think about. What is it? One is up, other is down. So we can always take everything up as positive and everything down as negative. So if you use this sign convention, right, what is the advantage we will be able to have? We'll at least have a fixed notion that, okay, so anything up we'll take positive, anything down will be what, negative. So either you go with that same sign convention that you are used to in the horizontal straight line motion, otherwise you can follow this sign convention. What is it? Anything up is positive, anything down is negative. Now while we are solving problems and all that, right, we will be using this sign convention, because when even we talk to students, in terms of where they could go wrong in the questions on vertical straight line motion. Often what we hear is this sign convention, and whoever is following this sign convention of taking everything up positive, down negative, because it's a surety. So you don't have to worry about, okay, so how the initial velocity is changing or something like that. So it's already fixed, up is positive, down is negative. So your chances of making mistake in the sign convention will be very much minimized. So we'll go with this sign convention while we are using these equations of motion. Why are we able to say that we can use the equations of motion? Because here the acceleration is fixed, which is g downwards. It's a uniform acceleration. So I'm writing, what are these equations? V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and then Sn, what is it? Displacement in the nth second. Sn is equal to what? U plus a by 2 into 2n minus 1. Now in these equations, right, one thing we have to be careful. What is it? The s here always represents what? Displacement. So s always represents what? The displacement. Okay, when the displacement will be equal to distance covered, if the object is in straight line motion without changing direction, then in that case displacement will be equal to, or the displacement magnitude will be equal to what? Distance covered. If it is changing direction, like here, what can happen? Imagine if an object is going up, it is reaching that maximum height, then it starts coming in the reverse direction. Then what is happening here? It is changing its direction of motion. When it is changing the direction of motion, right, if you calculate s from this formula, what are we going to get? We are going to get the displacement and not the distance covered. So we have to be careful about it. In fact, if you look at some of the past year JEE questions and all that, right, they would have asked questions related to this, where they will give, okay, so if it is in the vertical straight line motion, in this time t is equal to 4 seconds, what is the total distance covered? Like that they would have asked questions. So in that, one area which we have to be careful is the object changing its direction of motion? Already we have talked about it in a video that we made with regard to the horizontal straight line motion. We call it as what? Distance versus displacement problems. Okay, you may want to take a look at it, but here also we will have that kind of situation possible. Why? Because when the object is going up, remember, it is going up, but what about the acceleration? Acceleration is down. So it is like what? Under deceleration. So at some point, which is the maximum height point, it will start changing its direction. And hence, if you calculate the s from this formula, right, s is going to give us the displacement or not the distance covered. Okay, so these problems we'll look at it when we go to the specific case. Now what we'll do is we'll start with the first category. What is the first category? We are basically throwing an object upwards from the surface of the earth. Okay, so here as I said, this we neglect. So the assumption is what it is like, the person is standing very close to the surface of the earth and throwing it up. Okay, so when you throw it up, you will obviously throw it up with some velocity. So here this initial velocity is what? It is upwards. So if you say initial velocity is 20 meter per second, we have to take it as what? Plus. Why plus? Because it is in the upward direction. And this object, once we throw it up, it is moving under the influence of gravity. So what about the acceleration due to gravity? It is g, but downwards. So acceleration, as per the sign convention, right, we have to take it as what? Minus g. Why minus is coming? Because we are saying our convention is what? Anything up is positive, anything down is negative. Now what is the journey of this particular object? It will start going up, isn't it? It will start going up. It will go to this max height. So from the surface where you throw, this h is what is representing the maximum height up to which the object will go. Now when we say maximum height, right, what is the significance of that point? Because the object is going upwards. Once it is reaching that maximum height, it will start coming down. Means what? As it is going up, right, this object is clearly under deceleration. Means the velocity will keep on decreasing. It is not able to go any further up. Means what? At that maximum height point, the velocity is becoming what? 0. So at that maximum height, right? What is the final velocity? Final velocity will be what? 0, because that is the reason why it is not able to go any further up. Okay, now let us find out what is the time it takes to reach that maximum height, because we can use what? The equations of motion, right? We have initial velocity, acceleration, final velocity, and we have to find the time. What is the relation? V is equal to u plus 80, right? Final velocity, what is the final velocity here? 0 is equal to initial velocity u plus acceleration into time. Acceleration is what? Minus g into t. Look at this. The minus gt, we can bring it to the left side. Minus gt will become what? Plus gt. So gt is equal to u. We are looking for what? Time, right? So t will be equal to what? U divided by g. So this is the time in which the object will be able to reach that maximum height point. Okay, so this is the time in which the object will be able to reach the maximum height point. So what is the t? U by g. So these are all standard results. Like, if you remember this formula, right? If there is a question which is like, an object is thrown upwards with a velocity of 20 meter per second, how much time it will take to reach the maximum height? If you remember, the formula means straight, what is it? U by g, 20 by g. If you take g is 10 meter per second square, what is it? 20 by 10 means 2 seconds. Straight away we will be able to tell the answer. Okay, so this is the time it takes to reach that maximum height point. Then we can also find out what is the height to which the object will be raising, or this maximum height value itself. We can find what is this maximum height value. How we want to find this height? Now height is related to what? See, from the point where it is projected upwards, it is going to the height h. Means you look at the displacement, right? What is the displacement? Remember, from the surface, it is going upwards. Means displacement, you look at the displacement direction, it is what? Upwards. Displacement is what? Initial point to final point. So here displacement is going to be what? Positive, as per the sign convention. Because it is upwards, it will be what? Positive. So displacement will be equal to what? Plus h. If h is that height to which it is raising, displacement will be equal to what? Plus h, as per the sign convention. You have to be clear about the sign convention, because from the surface it is going to the height. Means look at the displacement direction upwards. So if, say for example, it is going to a height h, means in the sign convention we will have to use the displacement as what? Plus h. Now you see, we have initial velocity, we have acceleration, we have final velocity. We want to relate them to displacement. We want to relate them to what? Displacement. What is the equation we have? V square is equal to u square plus 2as. V square means what? 0 square. Final velocity square is equal to u square, initial velocity square, which is what? U square plus 2 into what is the acceleration? Minus g into what is the displacement? H. Okay, so while substituting in the equation, we have to take everything as per the sign convention. Okay, now look at this. What we'll have? Just bring this minus 2gh. LHS is what? 0. Minus 2gh, let us bring it to the left hand side. It will become what? 2gh is equal to u square. So we are looking for the h value. H is equal to what? U square by 2g. So what is the second result we have? H is equal to what? U square by 2g. So these two results we have to keep, because these will help us to quickly solve the problems. So what did we do? We have used that equation. What is the equation we have used? V square is equal to u square plus 2as. From there we are able to get what is the maximum height to which the object can go. Okay, so this is about the important standard results with regard to the vertical straight line motion of an object which we are throwing from the surface of the earth. Okay, so I'll just represent both the formula here. What is it? That maximum height to which the object is able to go will be equal to what? U square by 2g. And what is the time it takes to go to that maximum height? It will be equal to what? U by g. The time it takes to go to the maximum height will be what? U by g. We can also write it in terms of h. See, look at this. What is root 2h by g? In place of h, what we will say? U square by 2g. Okay, 2 is cancelled. What will have? Root of u square by g square means what is it? U by g. Okay, So what is the time it takes to go to that maximum height? It is what? U by G. We can also express the value in terms of that height attained by the object. Okay, either U by G or root of 2h by G. Okay, so this is about the formula for the time to reach the maximum height and also the maximum height value itself. Now we'll also have the other part of the motion, because the object is not going to go to the top and stop, isn't it? Because there is an acceleration due to gravity which is pulling it down, it will start coming down. It will start coming down. So here, when we look at the overall motion, what is it? It is going up to that maximum height location and then coming back. That is the overall journey. Time of flight basically means the time it takes for the entire journey. Time of flight basically means what? Time it takes for the entire journey. And also velocity on returning to the ground. So we'll do the derivation for what? Time of flight. Okay. So time of flight means what? The time it takes to come back. Time of flight means what? Time it takes to come back. So look at this. We are projecting it with some initial velocity. So initial velocity. So as per the convention, we will take it as what? Upwards means plus. Acceleration, see, it's like, fixed. For all vertical straight line motion problems, if we go with our sign convention, right, what is it? Always our acceleration will be what? Minus g. We can blindly just write it down. Okay, so acceleration is what? Minus g. Why? Because acceleration will be g downwards. What is our sign convention? Up means positive, down means negative. Okay, now look at it. What else we have? The object is going to go to that maximum height and then it is going to come back. Now when we look at the entire journey, right, what is the overall displacement? Think about it. What is the overall displacement? It is starting from this point. So imagine the height or the line where we have the person's hand. It's going up and then coming back. Now if you want to talk about what is the overall displacement, displacement means what? It is the shortest distance between initial point and final point. See, initially wherever the object is, finally also it is the same location, right? It is coming back. It's coming back again, which means what? The overall displacement is going to be 0. You have to pay attention to it one more time. What is it? Displacement means what? It is going up. That's fine. And then again coming back. We are looking at the overall journey. The overall journey means what? It goes up and then comes back. So initial point is coinciding with the final point of that particular object, means overall displacement will be what? 0. Now can we find the time? What is the formula we have? Think about it. Initial velocity, acceleration, overall displacement, time. What is the formula? S is equal to what? Ut plus half at square. Correct. What is the formula we have? S is equal to ut plus half at square. So S means what? Displacement. Displacement is what? 0. 0 is equal to u into t, means what? Initial velocity into t. Initial velocity is what? Plus half into a into t square. Here a means what? Acceleration. And what is the acceleration here? Minus g. This is equal to what? 0 on the left hand side. Displacement of the entire journey is what? 0. Now what we'll do? We can look at it. So what is it? Ut minus half gt square. So if we check it, right, we can take t common. U minus gt by 2. If we take t common out, what is there? From the first term we take t common out, means u will remain. Second term we take 1 t common out, means it will be what? G into 1 more t remains inside. G into t by 2. Okay. Now when you look at this, right, 0 is equal to t into u minus gt by 2. So here we'll have two possibilities. What are the two possibilities? What are the two possibilities that we can have? One is straight away t equal to 0, or u minus gt by 2 is equal to 0, which means u is equal to gt by 2. From here 2u by g is equal to t. So when we apply the condition of displacement 0, we are getting two roots for the time. What are the two roots? One root is telling us t is equal to 0, which is obvious. Why? Because t is equal to 0 means we have not even started the journey, right? In that case, what will be the displacement? 0. That is not what we are looking for. We know very well t equal to 0 means displacement will be 0 only. But what is our interest? Our interest is in finding what is the other value or the other root of t. What is the other root? 2 times u by g. So this is the time after which the overall displacement again becomes 0, which means what? This is the point where the object has returned to the ground. You might want to notice one thing. Time it takes to go to the maximum height. Generally, you know what we call it as? We will be calling it as a time of ascent. Ascent means what? Going up. What is the value? We already got it. What is the value? U by g. Previous discussion. What is the time of flight? Going up and coming down. What is the time of flight? 2u by g. You see one interesting thing. What is it? The motion is symmetric. To go up, it is taking how much time? U by g. Overall time is what? 2 times of that. Means while coming down also it is going to take the same amount of time. So generally we will call that as time of descent. The time it takes to come down will be called as what? Time of descent. Okay. So we'll see one interesting relation. What is it? The time of flight, which is the time it takes to go up and then come down. Time of flight is what? Exactly twice that of the time of ascent. Time of ascent means what? Time it takes to go to that maximum height location. Okay. Now we also need to find the other part. What is the other part? The velocity on returning to the ground. What is it we need to find? We have to find what is the velocity on returning to the ground. Okay. So for that we'll again look at the given parameters of motion. So initial velocity is what? Plus u. Acceleration is what? Minus g. We want to find the final velocity v. What is it? We have to find. Okay. And for the overall journey, what is the displacement value for the overall journey? Means what? The going up and coming down. Total journey displacement is what? Already we have used it. What is it? 0. Now initial velocity, acceleration, final velocity, displacement. What is the equation we have relating them? V square is equal to u square plus 2as. Correct. So v square, the final velocity square, that is what we have to find, is equal to what? Initial velocity square plus 2 into a is what? Minus g into s is what? Displacement. So this entire term is what? 0, which means what? V square is equal to u square. V, mathematically we can say what? V is equal to plus or minus u. Okay. But here, as per the sign convention, think about it. U will be up because we are projecting it up. While returning, the velocity will be in the downward direction. So we'll take the final velocity to be equal to what? Minus u as per the sign convention. Because plus means our convention is telling what? Up. Minus means it is down. So the bottom line is, on returning to the ground, the object will have the same velocity with which we projected. Like say for example, we are projecting it up with a velocity of 35 meter per second. On returning to the ground, it will have the same velocity of 35 meter per second, but downwards. Going up it is upwards, coming down it will be downwards. Okay, so this is about the time of flight and velocity on returning to the ground. Okay, so these standard results are the cases we are discussing, right? If you remember them, means it is going to be a lot of help for us while we are solving the problems. Next, another, it's a question itself. It's not even like a standard result, it's a question in itself, especially when we look at JEE mains type of exams, right? These kind of cases can be asked. So if you are throwing it from the surface with a velocity u, we know it will go to a height, that maximum height. Already we have the value also. What is the maximum height? What is it? U square by 2g. What is the time it takes to go to that maximum height? Also we know. What is the time it takes to go to the maximum height? T will be equal to what? U by g. Time of flight also we have derived. So we have done some analysis of this. But they can ask questions like this. What is the velocity at half the maximum height? Or they can ask what is the velocity at 1/3 of the maximum height? What is the time it takes to reach half the maximum height? What is the time it takes to reach 1/4 of the maximum height, like that? Now while solving these kind of questions, right, that is where the standard results will come very handy. Look at this particular case. This is like a question itself. We have to find what? Velocity at half the maximum height. What we are required to find here? Velocity at half the maximum height. Means, look at it, no. So here it is assumed that the initial velocity is given. As per the convention, you will take it as what? Initial velocity will be positive. What about the acceleration minus g? When we say it is at half the maximum height, see, half the maximum height means what? The displacement will be equal to plus h by 2. From the point where we are projecting it up, it is going to half the maximum height, right? Means displacement will be equal to what? H by 2. So displacement will be equal to what? H by 2. H is what? U square by 2g. That is why I said, if you remember these results, means it will come very much handy. So U square by 2g, this is the H, divided by 2, sorry, which is what? U square by 4g. This is what is the displacement. We have to find what? At this particular displacement, what is the final velocity. So we know the initial velocity, we know acceleration, we know displacement, we have to find the final velocity. What is the formula? V square is equal to what? U square plus 2as. 2 into acceleration is what? Minus g into displacement is what? U square by 4g. We can see here g is cancelled. 2 2's. So what is it? V square is equal to U square minus U square by 2, which is U square by 2. So V square is equal to U square by 2 means V is equal to what? Plus or minus U by root 2 if you take a root on both sides. But still the object is going up only, right? It is at half the maximum height, means it is going up. So what we can take? We can take that velocity there will be what? Plus U by root 2. Okay, so what is it that we need to keep in mind? The velocity will be what? Initial velocity value divided by root 2. So while solving problems like this, so they can ask what type of questions? They can ask what is the velocity at half the maximum height, what is the velocity at 1/3 the maximum height, or they can even ask what is the time it takes to reach half the maximum height, what is the time it takes to reach 1/5 of the maximum height. In these type of questions, if you remember this results, the maximum height and the time of ascent. Time of ascent is what? U by g. Total time of flight is what? 2u by g. If you remember the standard results, means it will come handy while solving problems like this. Okay, so this is what we need to be ready with regard to solving questions of throwing an object upwards from the surface of the earth. Okay, now we'll just look at a sample question on this. A stone is thrown vertically upwards. How are we throwing the stone? We are throwing the stone vertically upwards with a velocity 30 meters per second. So this is the u value. If the acceleration due to gravity is 10 meters per second square, so they are asking us to assume instead of 9.8, take it as 10. It will in fact ease our job only because it will simplify the calculation. What is the distance traveled by the particle during the first second of its motion? So look at it. We are throwing it up with how much velocity? 30 meters per second. What is the acceleration? Acceleration is what? Downwards, means we'll take it as negative. Okay, so look at this. Initial velocity u is equal to what? Plus 30. Acceleration is what? Minus 10. Okay, then the time is what? 1 second during the first second of its motion. Time is what? 1 second. Okay, so in that first second we have to find what is the displacement. We have to find what is the displacement. Okay, so here what is it that we need to be careful? We have to be careful with whether there is a change in direction or not, because remember, when we are projecting a particle upwards, what is going to happen? It is going to go up till it reaches that maximum height and then it is going to come back. So here we have to be careful about at what time. So let us call this time as what? T naught. At what time the object is going to change its direction of motion. So particularly in the JEE mains level, right, these kind of questions are very popular. They are not going to be tough. It is just that we have to be careful about the behavior of the particle as it is going in the vertical straight line motion. So if you look at this, T naught is what? The time of ascent. T naught is what? Time of ascent, right? The time which it is taking to reach the maximum height, because after that it is going to change its direction of motion. What is the time of ascent formula? U by g, which means what? U is 30 meters per second divided by g, we are taking it as what? 10 meters per second square. We can see here how much it is? 3 seconds. Okay, so we are safe. Why? Because it takes 3 seconds to go to that maximum height, means Up to the 3 seconds, there is no change in the direction of motion. Up to the 3 seconds, there is no change in the direction of motion. Here they are asking us what? The first second of its motion. Means in the first second, what is the displacement formula? Ut plus half at square. What is it? U is what? 30 into t is, everything is in the SI system. So we'll just keep the units away. S will be coming in terms of what? Meters. Ut plus half into a is what? Minus 10 into t square means 1 square. So 30 minus 5. So 2 ones are 2 5s are actually. 30 minus 5 means what? 25 meters. So this is the displacement. Remember, always from the equations of motion, what are we going to get? We will always get the displacement. S is what representing displacement. But since it is just going up in the vertical straight line without changing direction, because change of direction happens at t is equal to 3 seconds. In that first second of the journey, no change in the direction. Okay. So what is going to be the distance covered here? Distance covered also will be equal to what? It will be 25 meters. We have to be careful when there is actually a change in the direction. Okay, so if that is there means then the distance has to be calculated in a different way. Okay, already we have seen in that horizontal straight line motion, we have to break the journey up to that point where the direction is reversed and calculate the displacement value separately. Okay, so I'm assuming you would have seen that video of distance versus displacement calculations in horizontal straight line motion. Same concept we are going to use here also if there is a case like that. Okay, now some people will be having a doubt. Sir, no, we have used the formula of Sn. Correct. Sn is what? Displacement in the nth second. Here they are saying what is the distance traveled by the particle in the first second. So why are we using this S formula? Can we not do with the Sn also? We can do with Sn formula also, because first second of the journey means what? Either you say the total journey time is 1 second, or you say it is the first second of journey also. Correct. Now Sn formula is what? U plus a by 2 into 2n minus 1. What is the u value? U is what? 30 plus a is minus 10 into n is 1 first second, right? So what is it? 5. 2 into 1 means 2. 2 minus 1 is 1. Full away the 1. 5 into 1 means what? It will be 5. So what you have is 30 minus 5, which is equal to same 25. So first second of its motion means the total journey time is also 1 second. So either you can do it by using the S formula or Sn formula. But if there is a question, second of motion or third second of motion, then we have to use the Sn formulas only. If they ask what is the total displacement in 4 seconds, then we have to use the S value, because S represents what? Total displacement in a given time. Sn represents what? Displacement in the nth second of the journey. Okay, so this is how we can solve this particular question. So we have covered what is the first type of the or first category of the vertical straight line motion. What is it? We throw an object from the surface of the earth. In that we have seen what are the standard results that will be there, and we even seen one sample problem. It is not exhaustive coverage of problems. We can solve a couple of more problems also. But anyway, for the entire chapter together, right, we'll try to solve some questions so that we'll get some more comfort in terms of approaching the numericals. But because that is important while we go through the theory part, right? So how do we approach the numericals is equally important. Okay, so that we'll separately take it up for getting some more practice of the numerical questions. Okay, so in the next part, the second part video of this, right, we'll try to cover the other 3 types of the vertical straight line motion. Okay, we'll see in the next video.